Hello everyone, welcome back to my channel once again. So we are starting with the other questions where we have left, that is 1.10 from class 11th. It's first chapter we are doing. So the question is, in 3 moles of ethane, calculate the following: number of moles of carbon atoms, number of moles of hydrogen atoms, and number of molecules of ethane. So you have been given 3 moles, right? So whatever you have been given, write it down. You have been given that ethane is there. Its formula is C2H6 and its amount has been given, which is number of moles, that is 3 moles. Okay, so what we have to do, we have to calculate first, that is number of moles of carbon atoms, right? If you look at the formula of ethane, that is C2H6, you can see there are 2 carbons. Okay, that means 1 mole of ethane has how many moles of carbon? 2 moles of carbon atoms. Okay, carbon atoms. So if 1 mole of ethane has 2 moles of carbon, then how much 3 moles will have? 3 moles of carbon has 3 into 2 moles, that is 6 moles of carbon atoms. Okay, so this is how you are going to calculate it. Next is number of moles of hydrogen. Once again we are going to see that in C2H6, right, this is ethane. How many hydrogens are there? There are 6 hydrogens. That means 1 mole of ethane has 6 moles of hydrogen atoms. Okay, and how many 3 moles are going to have? 3 moles of ethane will have 3 into 6, which is 18 moles of hydrogen atoms. So once again, this is how hydrogen atoms has been calculated. Third part of this question is number of molecules of ethane. Okay, so as we know from Avogadro's number that 1 mole of ethane is equal to Avogadro's number, which is 6.022 into 10 to the power 23. Okay, over here ethane molecules, so molecules, right? If these much molecules are present in 1 mole, then how much is present in 3 moles? Once again, it is a simple multiplication. Ethane will have 3 moles of ethane will have 3 multiplied by 6.022 into 10 to the power 23. Okay, when you multiply it, you will get 18.066 into 10 to the power 23. Now you can convert it into the scientific terms. How we are going to convert? We are going to shift the decimal to this side, that is 1.8066 into 10 to the power 24 molecules of ethane. Okay, so 3 moles of ethane will have this much number of molecules. So this is a very simple question. As you can see, this question is actually based upon the mole concept. So if you know the mole concept very well, you can calculate this kind of question. Okay, let's go with the next question, which is 1.11. What is the concentration of sugar? Sugar has formula C12H22 O11. Okay, in moles liter inverse. You have to calculate the concentration. That moles liter inverse is molarity. Okay, so basically you have to calculate the molarity. If it's 20 gram, okay, the weight of sugar has been given. Okay, that is W of sugar has been given. Sugar is a solute. Okay, so 20 gram of sugar have been given. It is dissolved in enough water to make a final volume up to 2 liter. So volume of solution has been given. Okay, the volume of solution is 2 liter. Okay, we do not need water. Okay, because it is a molarity. From the formula you will get to know that we do not need waters, anything, that we do not need the volume, we do not need the mass of the water. Okay, so let's see, that is, what is the formula for molarity? Okay, molarity is number of moles of solute. Over here solute is sugar divided by volume of solution in liters. Okay, so basically we take it in 1 liter, but as you know that we have to calculate the number of moles. For that, what we are going to do, we have to actually first find out the molar mass of sugar. So molar mass of sugar okay, the formula is C12H22O11. So 12 multiplied by 12 plus 22 multiplied by 1 plus 11 multiplied by 16. So this is how you can calculate. Okay, this comes out to be around 342 grams mole inverse. Okay, so we can calculate now number of moles of sugar. Okay, number of moles of sugar is given mass, okay, divided by molar mass. So given mass is 20 gram divided by 342, right? If we calculate it, it comes out to be around 0.0585 moles. So number of moles are done. Now we can go back to our molarity equation. So we can calculate the molarity. Molarity is number of moles of solute, which is 0.0585 divided by volume of solution. The volume has been given 2 liters divided by 2 liters. Okay, and it is around 2, so obviously you are going to cut it. It is going to be 0.0, that is 2, then 9, then comes out to be once again 2, and then 5. So it is 0.02925. This is molarity, and we have been asked in question that we have to calculate the concentration in moles liter inverse. So obviously we are going to write it down, mole liter inverse, because this was in mole and this was in liter. Okay, so this is how you calculate this kind of question. Okay, let's go to our today's last question, which is this one. If the density of methanol has been given, which is 0.793 kilogram liter inverse, what is the volume needed, okay, for making 2.5 liter of its 0.25 molar solution? So methanol is solute over here. Okay, so once again we have been asked that what is the volume needed. Obviously molarity is given over here, we need the volume, then what we are going to do, first we are going to calculate the molar mass of methanol. Molar mass of methanol. Okay, and you should know that what is the formula of methanol. Methanol is C2H5OH. Okay, so from this formula you can calculate 2 carbons are there, 2 multiplied by 12, plus 5 hydrogens are there, 5 multiplied by 1. Then 1 oxygen is there, that is 1 multiplied by 16. Then once again there is one another hydrogen, then 1 multiplied by 1. Okay, you might add this hydrogen to earlier hydrogens also, but for the sake of easiness, I have done it like this. So when you do it, it comes out to be, this is 24, this is 5, this is 16, this is 1. Okay, so this comes out to be around 32. Grams mole inverse. Okay. Now, as you can see, there is in density has been given in kilograms. So can we do that? We can, convert this molar mass into kilogram also. Obviously, when we are converting into kilograms, we are going to divide it by 1000. Okay. If 32 is divided by 1000, then gram is converted into kilograms. Obviously moles is going to remain like that, and then you are going to have 0.032 kilograms mole inverse, right? All right, there are few things which are given. Shall we write it down? The density is given. Density is 0.793 kilogram liter inverse. Okay, then there is molarity is given. Molarity of the solution have been given. Okay, that is 0.25 molar, and we have also been given the volume of solution, right? Volume of solution have been given, that is 2.5 liter. Keeping these things in mind, we should calculate the molarity of methanol solution. Okay, so molarity of methanol solution, I'm really sorry, I'm writing it wrong. It's going to be methanol solution, right? What we are going to do, we are going to divide the density with the number of the molar mass. Density divided by molar mass. Okay, it is 0.793 kilogram liter inverse. I'm going to tell you why we are doing so. See, 0.032 kilograms mole inverse. Now over here you can see that kilogram is cancelled by kilogram, and mole inverse will surprisingly go on the top, and the unit becomes mole liter inverse, which is actually the unit of molarity. Okay, this is how we also can calculate the molarity also, if we are not given that how much volume is given. Okay, so we can use this formula. Okay, when we are going to solve it, it is going to be 24.78 moles per liter. Okay, fine. Now what we are asked over in the question, see, if the density of methanol is a liquid, you should know that. Okay, what is its volume? Its volume, we are asked about the methanol's volume. We have calculated the methanol's molarity. Can you see that where we are going? We are going towards the molarity equation. Okay, so we can apply the molarity equation, that is m1 v1 is equal to m2 v2. Mark my words that where this question or this equation is used, this equation is used where we have to know the unknown volume or molarity of one solution to make another solution whose molarity or volume has been given. Okay, these are four values. Among these four values, if one value is not given, that is unknown, and other three values are known, then you can use this molarity equation. Okay, so m1 v1. Okay, now you must know that what is m1 and what is this 1 stands for. Okay, we are taking m1 v1 for methanol. Okay, pure methanol, and m2 v2 for its solution. All right, so shall we go back? This volume of solution, okay, this is going to be v2. Molarity of the solution is going to be n2. Okay, and molarity of methanol is going to be m1. So we have three values with us, and we do not have the volume of methanol, which we have to calculate. So we add these values. Volume of methanol was, sorry, not volume, molarity of the methanol was 24.78 into V1 is equal to M2 was 2. M2 was 0.25. Okay, and volume was 2.5, right? So we can calculate V1 from here. 0.25 multiplied by 2.5, 24.78. If we calculate it, okay, you can do it 25 multiplied by 25, and then you will have one value, and then you will calculate it. If you will calculate it, it comes out to be 0. Because as you can see, it is a little bit, 24 and 25 are a little bit around each other, so it's going to be 0.0252, and it's going to be in liters. So can we convert it into milliliters? We can also convert it into milliliters. What we have to do, we have to take this value and multiply it with 1000. This is going to convert it into milliliters. So that is going to be 25.2 milliliters. Okay, so volume of methanol is going to be 25.2 milliliters. So this is how you will calculate this kind of question where volume has been asked. So I hope you all have understood that how these questions are calculated and how these calculations are done. I hope you have enjoyed this. Thank you so much. Have a nice day.